Assalamualaikum everyone. Today we will be dividing into an intriguing comparison between two major players in the world of operating system, Android and HarmonyOS. While Android dominates the global market, HarmonyOS, Huawei's innovative operating system, is proving to be a strong competitor, especially within its ecosystem. Our goal is to explore which of these systems provides greater benefits for developers by examining their ecosystem, device connection strategies, and developer environments.
As we know, one of the biggest distinctions between HarmonyOS and Android lies in the core architecture and design principles. HarmonyOS is built as a distributed operating system powered by a microkernel, which emphasizes modularity, security, and real-time communication. On the other hand, Android relies on a monolithic kernel where all essential and auxiliary services such as file systems and memory management are tightly integrated into the kernel space. Today, we will take a closer look at these two architectural approaches, breaking down their structure and understanding their impact on modern operating systems. Designed simply to basic cores, including virtual memory management, scheduling, and inter-process communication, a microkernel has a straightforward construction. Unlike monolithic kernels, which govern all system functions in one large unit, microkernels provide services including device drivers, file management, and Unix servers to user space. This technique offers several advantages. The system is more safe when most system operations are kept apart from the core kernel, therefore reducing possible vulnerabilities. Since failures in user space services do not compromise the entire system, general stability is enhanced also. Moreover, its modularity allows different parts to be replaced or upgraded without affecting the overall system. One drawback meantime is the additional performance or overhead resulting from more interaction between user space and kernel space. Like embedded and distributed systems, microkernels are nevertheless quite popular in contexts requiring great security, dependability, and adaptability. Now that we have explored the microkernel structure, let's take a look at another key operating system design, the monolithic kernel. Unlike microkernels, which divide functionalities into separate user space services, monolithic kernels integrate everything directly into the kernel itself. A monolithic kernel comprises several system components, including the virtual file systems, system calls, IPC, memory management, scheduling, device drivers, and dispatchers, where all functioning in a single unified area. This architecture provides a considerable benefit in terms of speed and efficiency. Since all services run within the same kernel region, there is no need for frequent communication between separate levels, which lowers processing delays and enhances performance. However, this tightly linked structure comes with drawbacks, which is a failure in any component might cause the entire system to crash, and implementing updates can be complicated as well, as changes sometimes require recompiling the entire kernel. Despite these issues, monolithic kernels continue to be commonly employed in high-performance systems due to their simplicity and efficiency. Since we have examined both microkernel and monolithic kernel architectures independently, let's compare them side by side to understand their essential contrasts and trade-offs. As we know that these two kernel designs follow independent techniques, each with its own advantages and constraints. The microkernel keeps the core system simple, delegating most services to user space. This increases security, stability, and modularity as errors in user space component do not crash the entire system. However, this architecture comes at the cost of performance as IPC imposes overhead. On the other hand, the monolithic kernel contains all key functions directly into the kernel area. This leads in high performance and efficiency as system components can interact without IPC delays. However, the consequence is reduced modularity, making maintenance and troubleshooting more complex. Additionally, a failure in any kernel component can lead to a system-wide crash due to the tightly integrated nature of the design. Ultimately, the decision between alternative designs depends on the specific needs of the system. Microkernels are suited for situations favoring security and fault isolation, but monolithic kernels remain prominent in performance-driven applications.
Next, let's discuss ecosystem integration. HarmonyOS stands out for its cohesive ecosystem. Its super device feature enables devices such as smartphones, smartwatches, TVs, and IoT devices to function as a single unified system. For example, users can seamlessly drag and drop tasks like switching a video call from a phone to a TV. Devices can also share hardware resources, such as using a smartwatch as a remote control for your other smart devices. In contrast, Android relies on Google's proprietary services like Google Drive and Google Play for ecosystem integration. While Android support device connectivity through tools like Google Cast and Google Nearby Share, these are often app-dependent. Additionally, cross-device integration is limited and relies on third-party manufacturer solutions, such as Samsung SmartThings. In short, HarmonyOS delivers a more integrated, efficient ecosystem for cross-device collaboration, while Android's ecosystem is versatile but less seamless.
Let's now explore about app development and regional focus. So let's start with HarmonyOS. HarmonyOS simplifies app development with tools like Dev Echo Studio, which support multi-platform deployment from a single code base. Developers can write code once and deploy it across multiple devices including smartphones, TV, and IT gadgets. The app compiler ensures optimized performance on all platforms, minimizing the need for manual adjustment. So how about Android? Android developers rely on Android Studio, which primarily use Java or Kotlin programming. While Android's app development tools are robust, they require a developer to optimize apps for a wide range of device and customization, increasing the development time and effort. So how about regional focus? Okay, so let's start with HarmonyOS. HarmonyOS was initially developed in response to US trade restriction. It has strong presence in China where Huawei's influence is significant and is gradually expanding internationally. Its ecosystem is tightly linked to Huawei's hardware, making it ideal for developers targeting this market. While Android in contrast has unparalleled global adoption due to support from numerous OEMs and widespread availability of Google service. However, in regions where Google services are restricted, HarmonyOS has the advantages. To summarize, HarmonyOS offers developers an efficient, unified platform and new opportunity in a growing market, while Android provides global reach but with higher competition and development complexity.
Next, let's discuss on how HarmonyOS approaches connection differently from Android. HarmonyOS stands out with its cross-device collaboration approach, which is powered by its distributive architecture. This innovative system allows devices within the same ecosystem to share capabilities and work together seamlessly. Let me explain how this works with a few examples. Firstly, drag and drop connectivity. Imagine watching a video on your smartphone and wanting to switch it to a larger screen, like a TV. With HarmonyOS, this is as simple as dragging and dropping the task into your phone to a TV. The transfer happens in real time, ensuring a smooth and uninterrupted experience. Secondly, resource sharing. Devices in the HarmonyOS ecosystem can share hardware resources like cameras, sense screens, and sensors. For instance, a smartwatch can act as a remote control for your other smart devices, ensuring a smooth and uninterrupted experience. Lastly, high efficiency and low latency. HarmonyOS ensures real-time communication between devices through distributed data management and accurate resource scheduling. This minimizes latency and provides a highly efficient and responsive user experience. These features make HarmonyOS ideal for creating a cohesive multi-device ecosystem.
Android facilitates device connection mostly through dedicated apps, such as Google Cast and Nearby Share. For example, if a user wants to operate a smart home device or stream movies to a TV, they normally need apps like Google Home. These apps act as middlemen, meaning the connection experience depends on the app's functioning rather than the operating system itself. Additionally, cross-device interoperability often varies by manufacturer. Samsung, for instance, has its own SmartThings platform to connect Samsung products easily, but this solution is limited to its ecosystem, decreasing interoperability with other companies. Another difficulty is latency. Since Android typically relies on cloud-based services for device-to-device connection, data has to go through intermediary servers, which can introduce delays, especially in real-time operations like screen sharing or smart home automation. While this strategy is functional, it lacks the deep system-level integration observed in other operating systems. As a result, consumers often rely on various apps and brand-specific solutions to achieve seamless communication.
HarmonyOS offers several features that significantly reduce the burden of developers and enhance the ability to innovate. Number 1. Unified code base for multiple platforms. HarmonyOS allows developers to write their code once and deploy it seamlessly across multiple hardware platforms, including smartphones, smartwatches, TVs, and IoT devices. This greatly simplifies the development process and minimizes the time and effort required to create applications for diverse devices. Number 2, ARC compiler for optimization. The ARC compiler in HarmonyOS ensures high performance by optimizing code execution. Developers no longer need to spend a significant time on manual optimization. This lets them focus more on creating innovative applications and enhancing user experiences rather than technical adjustment. Lastly is number 3, emerging ecosystem and market opportunities. HarmonyOS is still a relatively new and growing ecosystem, particularly in regions like China, where Huawei has significant influence. This provides developers with a fresh marketplace and the chance to build innovative apps for an ever-expanding user base. They can also tap into new niche and opportunities that are less competitive than Android-saturated ecosystem.
In contrast, while Android offers a robust development environment and global reach, it has a notable drawback for developers. Let's start with the first one, which is fragmentation issues. Android's vast ecosystem of devices from different manufacturers leads to fragmentation. Developers often need to spend extra effort ensuring compatibility across various devices, which increases the development time and complexity. So the next one is manual optimization needs. Unlike HarmonyOS, Arc compiler Android apps require significant manual optimization to run smoothly, especially on lower-end hardware. This can be a time-consuming process for developers. The third one, cross-device development complexity. Android lacks the seamless integration across hardware platforms that HarmonyOS offers. Developers must use different tools to enable interoperability between wearables, smartphone, and IoT devices, making cross-device development challenging. For the final one, market saturation. Android ecosystem is highly competitive and saturated, making it difficult for developers to stand out. In contrast, the HarmonyOS offers a fresh and less crowded market with more room for innovation.
To conclude, while Android is a powerful and widely adopted operating system, HarmonyOS provides distinct advantages for developers. Number 1, a unified codebase for multiple platform deployment. Number 2, efficient code execution with minimal manual optimization thanks to the ARC compiler. And lastly, number 3, opportunities to innovate in a growing and less competitive ecosystem. These features make HarmonyOS a better choice for developers who values efficiency, innovation, and the chance to explore new market opportunities. Thank you for listening.
In contrast, Android relies on Google's proprietary services. Google's proprietary